So, hello everyone. In today's lecture, we are going to solve some good questions based on the modulus, conjugate, and argument. We have seen their properties, what are conjugates, modulus, and argument. That also we have seen. So, based on that, we'll solve some problems. So, come to our first problem. First problem, they have given z is equals to 1 plus iota, 1 plus 2 iota, 1 plus 3 iota. And in denominator, they give 1 minus iota, 2 minus iota, and 3 minus iota. They asked to find the amplitude and they asked to find the modulus of the complex number z. So now first we'll find the modulus. So modulus of complex number z will be equal to modulus of the this whole 1 plus iota, 1 plus 2 iota, 1 plus 3 iota divided by 1 minus iota, 2 minus iota, 3 minus iota. So according to the property of modulus, we can distribute the modulus over division and multiplication about it. So this will be equal to modulus of 1 plus iota multiplied by modulus of 1 plus 2 iota multiplied by modulus of 1 plus 3 iota divided by modulus of 1 minus iota multiplied by modulus of 2 minus iota multiplied by 3 minus of iota. Now the modulus of 1 plus iota is under root of real part squared plus imaginary part squared. So here we'll get this is under root of 1 square plus 1 square, 1 square plus 1 square multiplied by under root of the modulus of this is 1 square plus 2 square multiplied by modulus of 1 square plus 3 square divided by under root of the modulus of 1 minus iota is again 1 square plus minus 1 square, which is 1 square only, plus under root of 2 square plus 1 square plus under root of 3 square plus 1 square. Got it? So here we will get under root 2 multiplied by under root 4 plus 1 is 5. Under root 5 multiplied by under root 9. Sorry, under root 10. 3 square plus 1 square is 9 plus 1, 10. Divided by root 2 multiplied by, here multiplication is there, this is multiplication, this also is multiplication. So here we'll get under root of 5 multiplied by under root of 10. So we can see root 2 and root 2 will get cancelled, root 5 and root 5 will get cancelled, root 10 and root 10 will get cancelled. So the modulus of this complex number z is 1. Now amplitude modulus we got. Now we will see how to find the amplitude. So amplitude and principal argument are same thing. Amplitude of z means we have to find argument only. So what are the properties of argument? Argument follows the properties that are similar to log, right? So the amplitude converts multiplication into addition and division into subtraction. So here we'll get, if we'll apply the property, here we'll get amplitude of or argument of 1 plus iota plus argument of 1 plus 2 iota plus argument of 1 plus 3 iota. Whatever is there in denominator, that will come with negative sign. So minus argument of 1 minus iota minus argument of 2 minus iota minus argument of 3 minus iota. Got it? Now we'll solve this one. The space is less, we'll copy first this one. So now this we have to solve. This will solve here. What is argument of 1 plus iota? This will be equal to tan inverse 1 upon 1 plus tan inverse of 2 upon 1 plus tan inverse of 3 upon 1 minus tan inverse of minus 1 by 1 minus tan inverse of minus 1 by 2 minus tan inverse of minus 1 by 3. So what we'll get after simplification? After simplification, we'll get tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3 plus tan inverse of tan inverse of minus 1. Minus if we'll take out, it will become plus tan inverse 1 plus tan inverse 1 by 2 plus tan inverse 1 by 3. Because if we'll take minus out, minus minus will become plus. Here also and here also. Got it? Now, what is tan inverse 1 plus tan inverse 2 plus tan inverse 3? Tan inverse 1 plus tan inverse 2 plus tan inverse 3 is equals to pi. While teaching inverse trigonometric function, I told to remember this value as a standard result. If you don't know the proof, I gave the proof in I button also. You can click there and you can check how this is coming as pi. And tan inverse 1 plus tan inverse 1 by 2 plus tan inverse 1 by 3 is equals to pi by 2. So if we will add both of them, here I'll get 3 pi by 2. Now, while teaching argument or amplitude, I told, see, they want amplitude. Amplitude means the principal argument. Principal argument lies from minus pi, open bracket, minus pi to pi, close bracket, pi. So it should lie in this range only. But this one is outside this range. So to bring it in this range, we'll take help of correction factor. So we'll add here 2n pi, which is my correction factor. We'll add here 2n pi, which is my correction factor. So we'll add 2n pi here. Now, to bring it in this range, what value of n I should keep? So it is more than pi, so we have to decrease this. So n value I'll keep here is minus 1. Keep n value as minus 1. So here we'll get 3 pi by 2 minus 2 pi. So this will be equal to 4 pi, 3 pi minus 4 pi, which is pi by 2 minus pi by 2 is our answer. Got it? Now next. This question we can solve in one more method. This question we can solve with one more method. Let's see the method 2 for this question. Method 2. If you will observe the given complex number carefully, they have given 1 plus iota multiplied by 1 plus 2 iota multiplied by 1 plus 3 iota divided by 1 minus iota, 2 minus iota, and here 3 minus iota. So what I will do, from numerator, from each and every term of numerator, from this term I am going to take I common, from this also I am going to take I common, from this also I am going to take I common. From these three, if you will take I common, you will get I cube. I cube. Now next, from this iota, if I take I common, here 1 will be remaining, and this will be 1 by iota. 1 by iota is minus iota. Now next, similarly, from here also we'll get 2, and this 1 will be 1 by iota. 1 by iota again is minus iota. And here also, if we'll take iota common, we'll get 3 minus of iota divided by 1 minus iota, 2 minus iota, and 3 minus iota. As you can see, these three and this are same. So this complex number, given complex number, is nothing but iota cube. Iota cube is minus of iota. Minus of iota. So where this minus of iota lies, if you will see, minus of iota will be somewhere here. Minus iota. Got it? So what is it? What is the argument or the principal argument for this complex number, which is minus pi by 2? Here we got amplitude of this complex number is minus pi by 2. Amplitude and principal argument are same thing. Now next they want modulus, right? Next they want modulus. What is the modulus of the complex number z? So the modulus of z will be equal to modulus of minus iota. Modulus of minus iota will be equal to 1. Got it? Read out. So easily we found method 2. Now come to next question. Next question they are given z is equals to 8 plus iota into 7 plus iota divided by 5 minus iota whole to the power 6. Got it? So first we'll find the modulus of this complex number. The modulus of this complex number z will be equal to modulus of 8 plus iota multiplied by 7 plus iota divided by 5 minus iota whole to the power 6 modulus. Now we know the property of modulus, that modulus of z, you know that z to the power n modulus is modulus of z to the power n. But this property will use, that means this 6 I can send out of the modulus. So here we will write here that it will be equal to modulus of 8 plus iota multiplied by 7 plus iota divided by 5 minus iota modulus to the power 6, and this will be equal to, now this modulus I can distribute. So here I'll get 8 plus iota mod 7 plus iota mod divided by 5 minus iota mod whole to the power 6. So we'll see here what is the modulus of 8 plus iota. 8 plus iota modulus will be under root of 8 square plus 1 square multiplied by 7 square plus 1 square, similarly 7 square plus 1 square divided by under root of 5 square plus minus 1 square whole to the power 6. So 8 square is 64 plus 1. So 8 square is 64. 64 plus 1 is 65. So here we got under root 65 multiplied by under root 50, 49 plus 1 divided by 25 plus 1, 26 whole to the power 6. Now here this all root I can take out. So here I'll get 65 into 50 by 26 to the power 6 by 2. So 26, 13 2s are 13, 5s are 65. Again I can cancel this 2 25 times. 25 into 5 is equals to 125. 125 I can write as 5 cube. So here I'll get 5 cube, and here 2 3s are 6. So into 3 I'll get. So here I'll get 5 to the power 9 is the modulus of this complex number z. Now next argument of this complex number or amplitude of this complex number. So we'll take this question next slide. Now we'll find the amplitude. The amplitude is nothing but argument in the range minus pi to pi, means principal argument. So here we'll get argument of this complex number z will be equal to, we can apply the properties of log. So in log what will happen? Power will go in multiplication. So here I'll get 6 times argument of the complex number 8 plus iota plus argument of complex number 7 plus iota plus minus argument of complex number 5 minus iota. So this will solve. Here we'll get 6 times the argument of this complex number is tan inverse 1 by 8 plus the argument of this complex number is tan inverse 1 by 7. The argument of this complex number will be minus of tan inverse minus 1 by 5. Now this minus will come out and it will become plus. First we'll solve these two. We'll apply the formula of tan inverse A plus tan inverse B. The formula is 6 times. Here we can write tan inverse of 1 by 8 plus 1 by 7 divided by 1 minus 1 by 8 multiplied by 1 by 7. Got it? Minus, sorry, minus minus will become plus, right, when I'll take this minus out. So it will be tan inverse 1 by 5. Now next, We'll take LCM. 7 into 56, so 56. And in numerator we'll get 7 plus 8, which is 15. And here denominator, also LCM is 56. And here we'll get 7 into 56 minus 1, which is 55. Got it. So this we got tan inverse of this. Here I have 6 times plus tan inverse 1 by 5. So here if we will cancel 56, 56 got cancelled. Here I have 5 3s are 15, 5 11s are 55. Now next, here we got 6 times of tan inverse 3 by 11 plus tan inverse 1 by 5. Again I'll apply the formula. So here I'll get 6 times tan inverse 3 by 11 plus 1 upon 5 divided by 1 minus 3 upon 11 multiplied by 1 upon 5. Now next 6 tan inverse, again we'll take LCM. 55, 5 3s are 15, 11 1 times is 11 divided by LCM will come 55. Here I'll get 55 minus 3. Now next is 55, and 55 I can cancel. 15 plus 11 is 36. Sorry, 26. So here I'll get 6 times tan inverse 26 upon 55 minus 3 is 52. 26 2 times is 52. So here we'll get our answer as 6 tan inverse 1 by 2. Tan inverse 1 by 2 is not a standard angle, so we'll keep our answer like this only. So 6 tan inverse 1 by 2 is the amplitude of this complex number z. Amplitude of this complex number z.